We'll quickly get started with phases of compiler in this video series. There are two phases of compilation. The first one is analysis, which is machine independent, and second one is synthesis, which is machine dependent. Compilation process is partitioned into number of sub-processes called phases. These phases are, the first one is lexical analysis. Lexical analyzer or scanners reads the source program one character at a time. This reading is done from left hand side to the right hand side, converting the source program into a sequence of numbers called tokens. So here you can see that there is an example statement here, a is equal to b plus c into 60. Let's say this is a random statement in a computer program. So this statement will be read from left hand side to the right hand side, and each element within this statement will be converted into a number. So once we give this to a lexical analyzer is going to convert it into a number. So let's say ID1 is a number which represents A, it's a unique number. ID2 represents B, ID3 represents C, and 60 represents 60. So number represents number. So this is how your lexical analyzer works, wherein it takes a source program and it converts it into numbers. And this is known as a set of tokens. So this particular set is known as set of tokens. Now, once this set of tokens has been done and the symbol table is generated, we go to the syntax analysis phase. So in syntax analysis phase, expressions, variables, statements, declarations, etc. are identified and stored into a symbol table. So within this syntax analysis, you can see that here the operators, the identifiers are identified. So the first one is equal to. So equal to has a left hand side and a right hand side. Then the plus symbol has been identified. Plus will be performed between ID2 and ID3 into 60. So here into has been identified. ID3 into 60 will be executed first. Then the product of that will be added with ID2 and then it will be stored onto ID1. So this is represented using syntax analysis. Now if we go to the next phase, this syntax analysis phase will be converted into an intermediate code. An intermediate representation of the final machine language code is produced here. So this set of tokens are also known as production. So this production will be converted into a machine code. So the machine code would be somewhat like this. First, this 60 will be converted into a real number 60. Once this is done, it will be multiplied with ID3 and it will be stored into a register known as temporary 2. Then the temporary 2 will be added with the content of ID2 and then it will be stored onto ID1. So this is the machine intermediate level code which will be generated using intermediate code generation. Once this is done, then code optimization will be done. Here you can see that the code optimization is done to improve the intermediate code so that the output runs faster and takes less space. So here what you can do is you can quickly see post code optimization, we can see that we can reduce this step integer to real 60. And what we can do is we can directly multiply ID3 into 60. So this conversion and storage process time will be saved and storage will be saved. So here it represents ID3 into 60 and it will be stored into temp1. And again, what we can do is we can directly concatenate or we can directly add temporary 1 with ID2 and we can store that into ID1. So in 2 steps, so here you can see that these 4 steps have been optimized into 2 steps and this is done under code optimization phase. Let's go to the next step. Here you can see that code generation will be done. So code generation is the last phase of translation. A number of optimizations to reduce the length of machine language program are carried out during this phase. The output of the code generator is the machine language program of the specified computer. Here you can see that this 2 set of statements using code generator will be converted into an assembly language. So here you can see that first of all we are going to execute a move function using which we are going to move the value of ID3 into R2 register. Then we are going to perform a multiply function wherein we are going to transfer 60 into R2. We are going to multiply 60 with R2. So here ID3 into 60 will be done at this stage. Then we are going to perform a move function wherein we are going to put the content of ID2 into R1 register. Then we are going to perform an add function wherein we are going to add the registers R2 and R1. And once this is done, we are going to move the value of R1 register into ID1. So this is how code generation will be done, and your compiled program is meaningful and it can execute on a machine. Now, in case if you would like to explain that in an examination paper, you can quickly write a diagram somewhat like this, wherein you can quickly take position is equal to initial plus rate into 60. This is the statement. You can send it to Lexical Analyzer. Lexical Analyzer is going to convert it into tokens. Tokens are numbers, and each number represents a unique keyword in the source program. Now these tokens, the set of tokens will be sent to Syntax Analyzer, wherein we are going to quickly check whether the statement is following the rules specified in the language or not, and this process I am going to practically demonstrate in the next video. Once syntax is correct, we are going to give it to Semantic Analyzer, wherein our Semantic Analyzer will identify whether the statement has a meaningful value and is it meaningful for the computer machine. So once this is done, it will be transmitted to intermediate code generator, wherein the assembly language intermediate code will be made. Once this code is ready, we are going to send it to Code Optimizer, which is going to remove unnecessary statements of assembly, and so as to make your program execute faster and takes less space. And once this is done, then the code generation phase will be done, wherein we are going to achieve the assembly code which will be understood by machine language. So thank you for watching this video session.